Okay, so in this problem, we're finding the slope of x squared at a specific point. Well, not exactly. At a point instead of an average slope. It's an instant slope, but we're solving it for a general point, x equals a. So if I were to draw x squared here, something like this, let's say that I'm just picking this point right here, a, f of a. So the idea is I don't actually know which point I'm picking, just a f of a. And then I'm trying to find the slope through that point. So what we would normally do is this: if this was like 1 f of 1, then I'd pick a point near it and call it a plus a little bit, or 1 plus a little bit, f of a plus a little bit. Ugh, hold on one second. And what I do is find the slope of the line through these two red points, which is y2 minus y1 over x2 minus x1. And again, these a's will on the bottom will always cancel. And then what I want to do is, that's the slope of a secant line. What I want is the slope of a tangent line. So I got to make the a plus h get closer and closer to a. That's by taking the h and making it get smaller and smaller and smaller. So this right here is the slope of f of x equals x squared at x equals a. Okay, so let's work this out. Okay, so I've got limit as h goes to 0, and a plus h, f of a plus h is a plus h squared, minus f of a is a squared, all over h. And then if I work that out a little bit more, I get a squared plus 2ah plus h squared minus the other a squared all over h. So these guys cancel. And then I can factor out an h from the top. 2a plus h all over h. Then these guys cancel. And at this point, I can plug in my h equals 0, and I get 2a. So why is this useful? The idea here is now I can, instead of you having to do this, like if I said find the slope at x equals 1, you'd put a, you do this whole thing, but instead of the a's, you'd have 1s. And then if I said find it at x equals 2, you'd say, okay, let me make all the a's 2 and work it out again. But really what you've done is you come up with a general formula. So now I can just say at x equals 7, well, you know the slope is going to be 2 times 7. It's going to be 14. So this right here is actually a kind of a blueprint for finding the slope at any x value you want for x squared. So that's actually basically what this is it's a slope function right here. I give you an x value, x equals 7, you plug it in, you get the slope right away on x squared. Okay.